Hey guys, in today's video I'll be showing you how to split algebraic fractions into multiple partial fractions. I'll start off by explaining what that means, and then I'll show you two simple examples of how to do it, and then I'll show you some more complex examples. So if you've got a algebraic fraction like the one here, if the denominator can be split into multiple linear factors, then it can be split into partial fractions like this. The method used to do this is relatively simple, but I've got two examples here that I'm going to show you on exactly how to do it. Step 1 is to separate out the algebraic fraction here into the two partial fractions with the linear factors as the denominators and two unknowns as the numerators. Step 2 is to multiply both sides by this denominator here. Essentially, multiplying by this denominator here cancels out the x had 1 on this one, leaving you with x had 4 multiplied by a, and cancels out the x had 4 on this one here, leaving you with x had 1 multiplied by b. The next step now is to substitute in two different values of x, both coming from these linear factors. The first being -4, that way this bracket here will be 0, cancelling out this whole side of the equation, and the other one will be -1, making this bracket here 0. Now we need to simplify both sides of the equation and solve for b. Now we have found a value for b, we need to do the same with the x value of -1 to find the value for a. Now the final stage is to insert these values here for a and b into the original partial fractions. So as you can see in this next example, the denominator hasn't been factorised yet, so that's the first step. It's a difference of two squares, which makes it very easy. And now we do the same step as over here, where we split it into two partial fractions. Now we multiply both sides by the denominator here, and then we substitute the values of 3 and -3 into the equation to work out what a and b are. Finally, we insert these values for b and a into the original partial fractions. Now here is a more complex example where you find you have a repeated factor on the bottom. So if you do have a question like this, then the method is slightly different. The first thing you want to do is split it into partial fractions. However, with the repeated root, you have 1, like so, and then the next one will be that root squared. So we have the repeated root of x add 1, and we get a over x add 1 add b over x add 1 squared. And then for the final one, we just do it normally. 2x add 1. And then from that point, we follow essentially the same steps. So we want to multiply out by the denominator. And then we want to substitute in some values. So the first one will be -1. And this -1 will cancel out this section and this section of the equation. And then the second substitution we want to do will be a -1/2 due to this factor, because -1/2 will make this equal to 0. And now, when trying to work out a, usually what we do is, as we've used both -1 and -1/2, I prefer to substitute x equals 0. As we already know the values for b and c, that will make this very easy. And now that we have values for a, b and c, we can simply put them back into the original partial fraction. Other types of questions you might find yourself being asked are ones such as this with more than two factors on the bottom. Now, this is just the same as if you had just two. All you have to do is add in more unknowns. And questions like this, where the fraction is improper, before you try and split it into partial fractions, you'll have to perform algebraic division, which I have a video on as well. So, if that video was helpful, then leave a like, and any topics that you want me to discuss or demonstrate in future, just leave a comment down below.